Okay guys, so let's begin the discussion for the JEE Main pattern exercises for the chapter sequences and series. The first question says that if the non-zero numbers 3 given are there, x, y and z, they are in AP, and tan inverse x, tan inverse y, tan inverse z is also in AP, then what is the relationship between these three numbers? So if x, y and z are in AP, that means twice of y is equal to x plus z, and if tan inverse x, tan inverse y and tan inverse z are also in AP, that means again that twice of tan inverse y is equal to tan inverse x plus tan inverse z. Right? Twice of tan inverse y means tan inverse 2y upon 1 minus y square. Right? Tan inverse x plus tan inverse z means tan inverse of x plus z upon 1 minus xz. If these two things are equal, that means their arguments are same. 2y upon 1 minus y square equals x plus z upon 1 minus xz. Now 2y is equal to x plus z. The numerators are equal. So automatically for these fractions to be the same, 1 minus y square equals 1 minus xz. This eventually means y square equals xz. So x, y, z are in AP. From here you can say x, y, z are in GP. So if three numbers are in AP as well as GP, then that only means that they three are equal. So we began with these three terms being in AP. Because of the second very argument given to us, we concluded that they are in GP as well, and therefore all these three numbers have to be same. Only then can they be in both AP as well as in GP. So that's how we deal with this question. Let's move on to the next one. Second question says that if three positive real numbers are in AP such that their product is 4, then what is the minimum value of B? Okay, so if A, B, C are in AP, that means B minus A is the common difference D, and that is same as C minus B. This means what? This means that A is B minus D, and it means that C is D plus B. Now if A into B into C is given to me as 4, what is A into B into C? A is B minus D, B is B, and C is B plus D. This is 4. This means B into B square minus D square is 4. Now, you know that B square minus D square is obviously less than B square. You can just take it strictly less as well. Fine. So B into this is less than B into this. So you get B into B square minus D square is less than B cube. But B into B square minus D square is actually 4. So 4 is less than B cube, or B is greater than 2 to the power 2 by 3. If B is greater than 2 to the power 2 by 3, that means minimum value is this. You can take it to be equal to, and then you are going to get it to be the minimum value. What is the minimum value? 2 to the power 2 by 3. Now the next question says what? That if B minus C, 2B minus X and B minus A are in HP, harmonic progression, then A minus X by 2, B minus X by 2, C minus X by 2 are in what? So if these three terms are in HP, that means their reciprocals are in AP. So if the reciprocals are in AP, that means 1 upon B minus C, 1 upon 2B minus X, and 1 upon B minus A, they are in AP. This eventually means twice of the middle one. Twice of the middle term is equal to sum of the first and the third. So 1 upon B minus C plus 1 upon B minus A. Very easily you can resolve this expression completely, and what you are going to get is B minus X by 2 whole square is equal to A minus X by 2 into C minus X by 2. Which means that what? B minus X by 2 whole square equals A minus X by 2 into C minus X by 2 means that A minus X by 2, B minus X by 2, C minus X by 2, they are in GP. So if These three terms are in HP, their reciprocals are in AP, because of which this is the relationship between them. Resolve it, you get this, which means A minus x by 2, C minus x by 2, B minus x by 2, they are in GP. Moving to the next question, if the first two terms of a harmonic progression are given to you as 2 by 5 and 12 by 23. So if they are given to you as 2 by 5 and 12 by 23, then the largest term is what in this HP? So the first two terms, first term of an HP is 1 by A, second term is 1 upon A plus D, because their reciprocals are in AP, right? 1 upon A is given to you as 2 by 5, 1 upon A plus D is given to you as 12 by 23. From here you can say A is 5 by 2, and again from here you can resolve and you can get D is minus 7 by 12. Nth term of the HP is given by what? 1 upon A plus N minus 1 into D. You have A, you have D, you are going to find this out. This is going to come out to be 12 upon 37 minus 7N. I want that N for which I can get the largest term. Now you can see if you put N equals 1, you get 12 upon 37 minus 7. See, one thing you understand, for this complete fraction to be the largest, the denominator has to be the least. This is going to be largest when the denominator is the least. For which N the denominator is the least, you can very clearly see, you can plug in N equals 1, 2, 3, 4, 5. At 5 you will have to stop because 6 is going to exceed it again. At 5 if you stop, you get 37 minus 35, which is 2. That is the least denominator you can get, for which you are going to get the largest value of this fraction, because if you move ahead of it, you are going to get negative in the denominator, which eventually is going to make the entire fraction negative, which is going to make it smaller in magnitude, right? So that is why for this complete fraction to be the largest, the smallest positive quantity which this denominator can gain is 2, that is when this difference is 2, that means when this is 35, which means when this is 5. So for N equals 5, that means for N equals 5 I am getting this term becoming the largest. So fifth term of this harmonic progression is the largest. Answer is option number A. Okay. What is the next question? Let's see if 3 arithmetic means, 3 geometric means and 3 harmonic means are inserted between 1 and 5. Okay. Then find the cubic equation whose roots are first AM, second GM and third HM between 1 and 5. So see, situation is, this is 1, this is 5, A1, A2, A3. 3 arithmetic means are inserted. I am only interested in the value of first arithmetic mean, which is what? It is A plus D, where D is B minus A upon N plus 1. So what is A1? A is 1, see, this is A and this is B. So 1 plus B minus A, 5 minus 1, that is 4 upon N is 3, 3 plus 1 is 4, you get 2. So 2 is the first arithmetic mean. Again, if you have 3 geometric means inserted between 1 and 5, what is the value of the second geometric mean? It is AR square, where R is B upon A to the power 1 by N plus 1. So A is 1, R is B by A, that is 5 by 1, square to the power 1 by N plus 1. So 1 upon 3 plus 1 is 1 upon 4 into 2, so 2 upon 4. This is root 5. And similarly, if between 1 and 5, you have 3 harmonic means inserted. If between 1 and 5 you have 3 harmonic means inserted, I am only interested in the value of the third harmonic mean. I know that 1 upon H3 is 1 upon A plus 3D, where D is A minus B upon N plus 1 into AB. And therefore 1 upon H3 comes out to be 1 upon 1, because A is 1 plus 3 times A minus B, 1 minus 5 whole upon N plus 1 into AB. So you get 1 minus 3 by 5, that is 2 by 5. So H3 is 5 by 2. That's how you get the first arithmetic mean, second geometric mean and third harmonic mean. These three are the roots of a certain equation, cubic equation. And when you know all the roots of this cubic equation, you can get the cubic equation, isn't it? The three roots are what? Suppose I am saying the first root is what we got 2, second was root 5 and third was 5 by 2. What is that cubic equation? It is x cube minus sum of the roots. Sum of the roots into x square plus sum of product of roots taken 2 at a time. So 2 into root 5 plus root 5 into 5 by 2 plus 5 by 2 into 2 into x minus product. So it is 5 root 5. That's the constant term. X cube minus sum of the roots into x square plus sum of product of roots taken 2 at a time into x minus product of the roots. And this is what, if you resolve, you get the first option as the correct one. Clear? Now moving on to the next, we have the sixth one, which talks about the series now. What does it say? Let's see. It says the sum of n terms of this series is what? Okay. So let's talk about this. What is the nth term? Nth term of this series will be 1 plus 3 plus 5 plus 7 plus and so on to n minus 1. What is this? What is this? I can write this as summation to r minus 1, r going from 1 to n, right? For r equals 1, this is 1, for r equals 2, it is 3, for r equals 3, it is 5, for r equals n, it is 2n minus 1. This gives you twice of summation r going from 1 to n minus 1, which is twice of n into n plus 1 by 2 minus 1, which gives you n square. This is actually summation r going from 1 to n till 1. 1 plus 1 plus 1 n times gives you n, so you get n square plus n minus n, which is n square. This is the nth term. You need to add the nth term. Basically, you need to find the sum of first n terms of this series. So you basically need to find what? Summation r square, r going from 1 to n, right? Because that's what we've got. So it is n plus 1, 2n plus 1 by 6, and that is your answer. So just generalize the very nth term. You need to add the nth term n times basically, right? So it is summation r square, r going from 1 to n. Okay? So the first term is this, second term, third term. You need to add, basically find the sum of n terms of this particular series. Clear? And that is coming out to be n plus 1, 2n plus 1 by 6. Now we have the next question in the league. It says if n is even, then the sum of n terms of this series is what? So n is even. Now please observe the very expression carefully. If you are going to see, with even numbers there is a minus sign, with odd numbers there is a plus sign. With even there is minus, with odd there is plus. So if this series stops at an even number, it is going to look like what? 1 square minus 2 square plus 3 square minus 4 square. End is even, so it will be minus n square. Before it is odd, so it will be plus n minus 1 whole square. 1 less. 1 less. So here it is even, so minus 1 less with plus sign. So this is what you get. Now when you eventually open this up, what is it that you obtain? You get a square minus b square. It is a plus b, a minus b, again a plus b, a minus b, again n minus 1 minus n, n minus 1 plus n. You solve this, you get 1 plus 2 plus 3 plus and so on till n, which is negative of n into n plus 1 by 2, and that is what is very simply your sum. Just understand carefully, if you are stopping at even number, before it comes a minus sign, and 1 less of it, which is an odd number, obtains a plus sign. Now moving on to the next question, we have the sum to n terms of this series is what? Okay, let's talk about this now. You can very easily observe it is of telescopic form. How do you write the general term, that is the rth term? It is 1 upon 2r minus 1 into 2r plus 1, right? You know you can write this as 1 by 2, 1 upon 2r minus 1 minus 1 upon 2r plus 1 for all r. That's what we've learned, right? And so if I talk about adding all these, when you add all these terms, first n basically are going from 1 to n. When you add the first n terms, this is the rth term, you get 1 by 2 is outside, you get r going from 1 to n, 1 upon 2r minus 1 minus 1 upon 2r plus 1. Eventually when you open this up, what you get is, for r equals 1, you get 1 upon 1 minus, for r equals 1 you get 3, minus 1 upon 3, plus then you get 1 upon 3 minus 1 by 5, plus then you get 1 by 5 minus 1 by 7, plus and so on. What you get is 1 upon 2n minus 1 minus 1 upon 2n plus 1. You can very clearly see everything like this gets cancelled. You are just left with 1 minus 1 by 2n plus 1. This gives you 2n plus 1 minus 1, which is 2n upon 2n plus 1. 1 by 2 is sitting outside, 2 cancels out. You are left with n upon 2n plus 1. Right? So if n upon 2n plus 1 is the answer, option C is the correct one. That's how, just by using the concept of telescopic series, breaking it up like this and then eventually opening the entire expression, cancelling out the terms which are getting cancelled, you are left with this, which is very easy to further evaluate. Now moving on to the next question, we have, if the sum of an infinite GP is equal to the maximum value of this function in this interval. Okay, so there is a GP, infinite GP, whose sum is equal to the maximum value of this function in this interval. Now look at the function. It is x cube plus 2x minus 8. How to get the maximum value of this function in this interval? If you carefully observe, f dash x is 3x square plus 2, which in this interval, you keep any value in place of x from this interval, this is always going to be greater than 0, which means that f is strictly increasing function. And if f is a strictly increasing function on a closed and bounded interval, at this point it is going to attain its maximum, and therefore f of 4 is the max. What is f of 4? 4 cube, 64, plus 8 minus 8, that is 64. So you are saying there is a GP such that sum of infinite terms of that GP is coming out to be equal to 64. So I can say A is the first term, R is the common ratio of that GP, then A upon 1 minus R is actually 64, because this is the sum of an infinite GP. This is given to you. Further, it is saying that sum of first two terms of that GP is 8. First term of the GP, second term of the GP. Sum is 8. That means A into 1 plus R is 8. From here you get that A is, or let me write, so A is 64 into 1 minus R. Plug it in over here, you get 64 into 1 minus R into 1 plus R is 8. So 64 into 1 minus R square is 8. 1 minus R square is 8 by 64, so that is 1 by 8. R square happens to be 1 minus 1 by 8, which is 7 by 8. And therefore R is going to come out to be root over 7 by 8. So it is saying what is the common ratio of the GP? It is nothing but root over 7 by 8. This is complete root over 7 by 8. Or you can calculate root 8 separately, that is 2 root 2, you can also write that. So you have root 7 by 8 happening to be the answer of this particular expression. Fine. So it's a very, very nice question. Here GP is being basically connected to the increasing decreasing part of the function. This is pretty interesting. This was very easy to evaluate the maximum value because you can see that this function is always strictly increasing. So it is going to attain its very max at the very end point, which is 4. Now moving on to the next question, we have fx is a polynomial of second degree. If fx is a polynomial of second degree and f of 1 is same as f of minus 1, also it is saying that a, b, c are in AP, then f dash a, f dash b and f dash c are in what? Okay, so let's understand f is a polynomial of second degree, so I can write fx as ax square plus bx plus c. Now f of 1 is given to me as same as f of minus 1. F of 1 is a plus b plus c. F of minus 1 is what? This is f of 1, f of minus 1 is a minus b plus c. When you solve this out, you get b is 0. If b is 0, fx is what? Ax square plus c. If this is fx, what is f dash x? 2ax plus 0. I am saying f dash a, f dash b, f dash c. So f dash a is 2aa, f dash b is 2ab and f dash c is 2ac. Are they in AP or GP or HP like what? Claim is that because small a, small b, small c are in AP, that means twice of b is equals to a plus c. These three are also going to be in AP. You can check. If you do twice of 2ab, this is 4ab. And if you do twice of a into a plus twice of a into c, this is going to be 2a common, a plus c, but a plus c is same as 2b. So this is this, which eventually is 4ab. And you can see they both are equal. And therefore, if small a, small b, small c is in AP, then f dash a, f dash b, f dash c is also coming out to be in AP. And that completes our discussion about these questions. That's it from my side. Thank you.